Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. Hofmann exhaustive methylation elimination concept. Each Hofmann elimination cycle consists of 1. Exhaustive methylation of the amine with excess CH3I to form a quaternary ammonium salt. Then, 2. Treatment with AgOH and heat to cause E2 elimination, producing an alkene and trimethylamine, or a tertiary amine that can be further methylated. The number of eliminations required equals the number of times nitrogen must be freed from cyclic constraints before it can leave as trimethylamine. A nitrogen in a simple chain needs 1 elimination. Each ring the nitrogen is part of requires 1 additional elimination to open that ring. Key rule: number of Hofmann eliminations is equal to number of rings containing nitrogen plus any additional constraints. More precisely, if nitrogen is part of n rings, it requires n eliminations to fully open all rings and release n, CH3, 3. A. Indolizidine, bicyclic, n at ring junction of 2 rings, a 6-membered and a 5-membered ring, both containing n is part of 2 rings. First elimination opens one ring, second opens the other, but after each elimination a new amine is formed that must be remethylated and eliminated. For a bicyclic system where n is at the junction of 2 rings, 3 eliminations are needed. First opens one ring giving a monocyclic amine still in a ring, second opens that ring giving an open chain amine, third. Actually, bicyclic with n at junction requires 2 eliminations to open both rings, then 1 more. Let me re-examine. For indolizidine, n into rings elimination 1 opens one ring monocyclic amine, still in one ring, elimination 2 opens that ring open chain tertiary amine, elimination 3 removes n as NMe3. So answer is equal to 3. B. Spiropyperidine, n in only one ring. The spirocarbon is not n is part of only one ring, piperidine. One elimination opens the ring, giving an open chain amine. Second elimination removes n as NMe3. Answer is equal to 2. C. Bridged bicyclic amine where n is at a bridgehead, part of 2 rings in a bridged system similar to A, n is constrained in 2 rings. Requires 3 eliminations, open ring 1, open ring 2, then final elimination to give NMe3. Answer is equal to 3. D. Primary amine on a norbornane side chain. CH2NH2N is not in any ring, it is a primary amine on an exocyclic carbon. After exhaustive methylation gives quaternary salt, 1 Hofmann elimination removes n as NMe3 with formation of an alkene, is equal to CH2. Answer is equal to 1. E. Benzaspine type, n in one ring. The 7-membered ring, benzene ring does not contain n. One elimination opens the 7-membered ring open chain amine attached to benzene. Second elimination removes n as NMe3. Answer is equal to 2. F. Tricyclic with n in 2 rings. The 5-membered pyrrolidine ring and the 6-membered ring of isoquinoline framework both contain n is part of 2 rings. By the same logic as A and C, 3 eliminations are required. Answer is equal to 3. Summary. A. Indolizidine, n into rings 3, B. Spiropyperidine, n in 1 ring 2, C. Bridged bicyclic, n into rings 3, D. Exocyclic primary amine, n in 0 rings 1, E. Benzaspine, n in 1 ring 2, F. Tricyclic pyrroloisoquinoline, n into rings 3. Therefore, the correct answer is A. 3, B. 2, C. 3, D. 1, E. 2, F. 3. Therefore, the correct matching is A matches 3, B matches 2, C matches 3, D matches 1, E matches 2, F matches 3.